Charles Jansky founded the science of radio astronomy just before the Second World War. Fast forward to the 1960s, and radio astronomy is a well-established discipline which has already made many great discoveries. At this time, in the mid-1960s, a young researcher called Jocelyn Bell has started to research her PhD on seeing if she can see if radio sources twinkle. Just like we see stars twinkling, varying in brightness very rapidly in the night sky, also radio sources can show this phenomenon as well, which tells us a little bit about what size they are and what kind of radio source they might be. In order to do this work, Jocelyn Bell had helped in the construction of a radio telescope which would allow the brightness of radio sources to be tracked as they varied in brightness very, very quickly. One day, as the telescope was making its observations and the radio brightness was being recorded on an old-fashioned chart recorder, something very strange was noticed. There appeared to be a very regular pulsing coming out of the chart recorder. There was a bright pulse in the radio once every 1.3 seconds or so. Now, usually regular pulses like this are associated with something that's being created by us. Maybe it's an electric fence nearby or something like that. But Jocelyn persevered, and she noticed that this signal was coming back about once a day, in just the same way that Jansky's signal had come back once a day. And so there was very strong evidence that this was actually a radio source from beyond our solar system. What had actually been discovered were pulsars, dead stars that have collapsed, and as they collapse, they spin faster and faster and faster. They produce radio waves which are a little bit like the light beam from a lighthouse, and every time that beam of radio waves sweeps across the Earth, we get a single tick coming from them. This was a really significant discovery. Pulsars are interesting in themselves, but as we'll learn later in the course, there's also a huge amount of really interesting science that you can do with them. And it remains controversial that Jocelyn Bell never won the Nobel Prize for her work. At around the same time, two American researchers were working on characterizing an antenna, which was going to be used for experiments with satellites. They were working at relatively high frequencies, and what seemed to be happening is, however hard they worked to get rid of interference and sources of noise within their own receiver, there seemed to be some extra noise which they simply couldn't account for. The strange thing was, though, that wherever they pointed their antenna on the sky, they received exactly this same noise. After many, many months of painstaking research, they came to the conclusion that there was no other possibility than this was a real signal which was coming into the radio telescope no matter where they pointed it in the sky. Eventually, news of this curiosity reached some theoretical astrophysicists, and immediately they knew what this was. This was the cosmic background radiation which was predicted by Big Bang theory. So once again, this was a huge discovery. We've talked about three different radioastronomical discoveries: the original discovery of radio waves from the galactic center, the discovery of pulsars, the discovery of cosmic microwave background. All of these discoveries required the use of innovative technology. What's also quite striking is that none of these researchers actually set out to make these specific discoveries. They were actually looking for something else. And the great discovery turned out to be serendipitous. The lesson that I take from this as a scientist is that it always pays to pursue the anomaly. If you find something that's strange in your data, it's a bad idea just to assume that this is something that's uninteresting. It's always worth making sure that you understand your data, because you never know what your data might be trying to tell you.